I think we will see those differences in the understanding of what the code is saying in those results of the benchmarking, because they are very different. And we had this discussion about the stabilizing favorable, unfavorable, and so on, also for other clauses. And it seems that everyone is understanding different things. So maybe the code or a guidance should clarify when to apply it and when not to apply it. Because, again, the engineering judgment will say you something, but after that you are reading whatever it is written in the code, and suddenly you feel that it's another thing that you have to apply. Yeah, for the benchmarking results regarding the retaining structure, we choose exactly this example that Sebastiano showed you before, giving the two design situations, so I will not repeat all this, and also the values and the main assumptions. And here are the same results that Sebastiano in TGB2 obtained, with the maximum values that were obtained in material factoring approach, and those obtained for RFA, and for the toppling using VC2 with the two combinations. So the final results from TGB2 was 3.4 meters, the required width. So we only received two solutions, so it is very difficult to have a conclusion after only two people solving this example. One came from North Macedonia and one from Slovakia. The one from Macedonia, the North Macedonia, only used RFA and only the design situation 1, if I understood well what they did, with no groundwater at all, and this was the final results, 1.84 instead of 3.39. And the solution from Slovakia, it is very difficult to understand because they didn't provide much details, but they analyzed both design situation, obtaining 2.5 and respectively 3 meters in the required width. So with this, we are approaching what was found by TGB2, even though it's not exactly the same number, but with the others, not really, we are quite far away of this. So it is difficult to conclude, but now we can understand a little bit where is this coming from, either from a different understanding of MFA, RFA. They didn't check both of them, so this is probably a national choice that has been done previously with the first generation of the Eurocode, so they did it according to their national practice. Also in Romania, we are not applying RFA, so probably we would not do it with RFA, but only with MFA. And also this thing, how to apply the partial factors to the favorable, unfavorable, or components, seems to be tricky, and this can also explain these differences. The second, I cannot comment more on two solutions, one of which is not giving much detail, so I cannot understand fully whatever was done behind. The second exercise for the benchmarking was the single propped embedded retaining wall in drained conditions. So here is the schematic problem that was asked to be solved. We asked for using limit equilibrium calculation and or soil structure interaction analysis. Some did both, some others only one of those options. Again, we gave only representative values for not complicating our lives with the determination of the characteristic values, and also the assumptions regarding the groundwater table. These are the other assumptions for the two layers of soil. Regarding the Young's modulus, linear variation with the depth, values for K0 and Poisson coefficient for each of those two layers. And for the structural properties, we gave the wall bending stiffness, a wall length of 18 meters for the soil structure interaction analysis and the probe stiffness. And only the drained analysis was required. And here are the TGB2 results, which are not presented in detail in this very short presentation I'm making, but you will find full details in the TGB2 report. So here are all the possible combinations for limit equilibrium, and the maximum value of the embedment depth was found when applying VC1 and RFA, and also the maximum bending moment, maximum shear force, and maximum prop force were found for the same RFA plus VC1. And here we can see for soil structure interaction only MFA with the two combinations. We can find here in MFA combination B together with VC3 5.10 meters the embedment length, but the values for the structural forces are much lower than those found using the limit equilibrium method. And here are the results that we got from the 4 solutions received, one from Romania, one from Finland, one from Hungary, and one from Slovakia. And yeah, here is it's not a reference value, it's just the solution given by one member of TGB2. We will not take this as a reference, but this is almost 6 meters. In Romania, very close to this, a little bit less, the smallest value found by Finland. We had 2 solutions, no, only one solution from Hungary, but with 2 approaches, RFA and MFA, very similar. And from Slovakia, a very, very big value here. I couldn't understand exactly why this 15 meters of embedment length was found. In terms of maximum bending moment, however, here we have a very big value found by TGB2 and smaller ones found by all the others. So that's clear that there is a difference in understanding of the provisions of the code. You can see here the maximum shear force. Again, TGB2 is the maximum value. And for the prop force, however, Slovakia is given a higher value than TGB2 and all the others smaller. Here are some details when regarding more in depth the solutions provided. TGB2 used finite element method, Plaxis software. The guy from Romania used three approaches or 3 methods: limit equilibrium method for ULS, and also for ULS the finite element method, and also checked the SLS. In Finland, they used only MFA, and they also checked by using the soil structure interaction. In Hungary, for RFA, they used the subgrade reaction, and they used former DA2 star from the previous code, okay? And when using MFA, okay, there are no other comments. And for Slovakia, we don't have details, so we cannot fully understand what they did and why they obtained such big embedment of 15 meters. So what can we conclude from here is that, of course, even if we are calibrating very carefully and giving the exact values and all the details in order to people to approach it in the same way, this is a kind of geotechnical structure that is giving many differences, because the methods are giving different results. Some of the designers are trying to optimize, some others no. Some others just took the 18 meters value, and if the checkings were accomplished, they said, okay, 18 meters, it's okay. The others try to optimize and to check the minimum embedment length that is fulfilling the requirements or the verification. So there are different approaches, let's say more academic ones and more practical oriented, let's say. So we saw that there are different calculation conditions, different hypotheses. This optimization that in some cases was missing, and in some cases there were no details, so we don't know exactly what happened there. And also we can see mixing, people are mixing provisions from the previous code, the national annex to the previous code, and the current one, so they didn't apply only the current one as it was required in the exercise. So this is what I can tell you about these two examples done in the benchmarking. Thank you.